Hello, everyone. A very good afternoon. I would like to thank you all for joining us today. My name is Aparna, and I'll be hosting this webinar. Before we get started, please let me take a few minutes to introduce Payatu. Payatu is a research-powered cybersecurity consulting firm. We have a decade-long track record with a singular focus on cybersecurity. The foundation of Payatu rests upon three pillars: community and conferences. Community and conferences encompass NULCON, an international security conference, training, and exhibition platform, and Hardware.io, a hardware security focused conference along with other initiatives. Consulting and training focuses on thorough security assessments, which helps businesses to discover security threats and further provide training to strengthen network infrastructure. Lastly, we have three offerings: IoT Auditor, an IoT security testing and compliance platform; Exploity, it is an open source IoT security testing framework; Exploity Academy, a comprehensive online learning platform that empowers professionals with the knowledge and skills to excel in the field of cybersecurity, particularly in the context of securing IoT devices. Here is an overview of the various consulting assessments we are known for across the globe. Payatu has delivered many cyber talks and workshops in top security conferences that also includes Black Hat and DEF CON. We take pride in the decade-long impact we have created by contributing in the cybersecurity community all around the world. With this, we started a community which is called the Payatu's Telegram community. With this, we aim to educate various organizations with industry-specific cybersecurity content. That was all about Payatu. Today, Arjun, Payatu's security consultant, will deliver a webinar on auditing a smart contract. You can read all about him on this slide. But before I hand it over to him, I would like you all to follow a few housekeeping tips. Please be on mute. If you have a question, you write it in the chat box. Arjun will take over these questions after the end of the session. Lastly, I would request you all to adjust your window to fit to window setting for this particular session. We will be releasing the recording of this session by on our digital channel. So make sure you are following Payatu. If you're not currently following Payatu, please check the links provided in the chat box. Without further ado, let's get started. Arjun, over to you.
Thank you, Berna. So hello, everyone. Welcome everyone. So before we start our webinar on auditing a smart contract, so I'll give you some background about me. So I work as a code review lead at Payatu. I specialize in application security, and this role has allowed me to expand my horizons as secure by design engineer. So for now, apart from the day job, I am working as a Web3 security expert, and sometimes I audit code at Code Arena, Cantina, and Sherlock. So let's start what you're all here for. Flash loan. So what is a flash loan? But before we dive into what flash loan is, let me give you a backstory. So there is a user. So you all can see there is a user. There are two dexes. So dexes are just decentralized exchanges. So these exchanges are nothing different but same as a stock market, but not centralized. So not centralized means these are not controlled by a single entity, rather controlled by multiple entities. So coming to this slide, so this user has a balance of $5 in his account, and these dexes has a listing of ETH, that's Ethereum. Dex A has Ethereum with the price of $5, and the same Ethereum is of $6 on Dex B. And this user notices this, and he tries to buy the Ethereum from Dex 1, which is Dex A, with $5, and now he has one ETH, but his balance is 0. And now ETH count is 1, his balance is 0, right? Now he sells his one ETH on Dex B, and he gains $6. So the net profit is $1 because he sold $5 worth of ETH with $6, so his net profit is $1. So this change of price difference index is called arbitrage. This user had initial balance of $5, but what if we had a huge amount of investment, let's say $5,000, right? So he will have huge profit of $1,000. But what if? But there are some factors to gain profit, to gain benefit from this arbitrage, right? So first would be the price difference. So I've taken example where the price difference is huge. That is $1 in the prices of ETH, but it's not very huge. It's nominal. And additionally, these dexes charge some fees, which is called on-chain transaction when you buy any coin from these dexes. So if the profit is minimal, right? So this nullifies your overall profit, overall benefit from this arbitrage. But if you have a huge investment, let's say you need to be a whale to gain benefit from this arbitrage mechanism. But if you don't, you can just take a loan and we can have a flash loan. So flash loan is a contract that lends this user some funds for a limited amount of time and get to collateral free. So what it does, I'm giving you what this contract does. So let's say there's a user, this user asks this contract is a flash loan for let's say $1,000. This contract, which is a flash loan, gives this user amount of $1,000 to him as a lender, right? Which is a collateral free amount. And by the end of the transaction, the user has to repay it back to the contract. Otherwise, it will revert. This whole transaction where the contract gave $1,000, it will revert back to original, and the user won't have any benefit while taking this flash loan. And behind the code, this is the logic of this flash loan contract. Let me walk you through. So if you see here in this code part, so there is a starting balance variable, which is used to calculate the number of tokens present in the contract. So this contract is a flash loan in this case. This is the flash loan address, right? Next, next line here, the token is transferred to the borrower's address. And in the next line, there is an ending balance variable, which is assigned to the variable ending balance, and it checks what is the balance of the contract of this token. So basically number of tokens present in this address, right? Now, if it is less than the starting balance, then the whole transaction reverts. So there is a logic behind this flash loan. So this is a very basic smart flash loan contract logic, but when we go on chain, the logics are very complex. This is just a basic one. Now we shall look at the code now, which we are going to audit. Okay, so the process would be we'll be reading the scope of the contract of the protocol. We'll read the white papers and to read by reading this white papers and readmes, we'll get an overall top level understanding of the protocol, and we'll have we'll understand the terminologies used in the contracts. And I'll be using this ID of VS Codium and you can use any of your choice. Then we'll be building the code using Foundry. Foundry is a development suite for building the Solidity contracts, and Fuzz is the command that is used to call the Foundry, right? So we'll be using Foundry to build the contract. And we'll be using Solidity metrics. Solidity metrics is a VS Code extension. So we'll be using Solidity metrics to calculate the complexity of the contracts. Then next we'll use the Foundry test coverage. So this coverage will uncover the blind spots, basically the low-hanging fruits, or where the developers might have missed testing the functions. So where they will be using Foundry coverage for that, test coverage for that. Then we'll be using Slither or Aderyn to find the low-hanging fruits. That basically these are static tools, same as in Web 2, where we run the tools and it scans for the low-hanging fruits. Then I'll be going for manual audit, and wherein I'll use inline bookmarks. Again, it's a VS Code extension. So it will help us when we go for second pass or multiple passes. It will help us to bookmark the code, right? So then we can bookmark the code where it's an issue or an error or information, right? So we should review the code through multiple passes, and this inline bookmark will help us a lot in that. Now let me share the code and we'll follow the same process. So the first was reading the white paper or the scope. So we have a readme file here. So if you can see where readme file, it gives us the basic understanding of what protocol is, what are the terminologies, what is asset token, which tokens are the asset tokens, be it USDC or ERC20. So this gives us a gist of the protocol, how we are going to build it. So this README file gives us that. The next is we're going to use ID to build this project. Now we move to our, so this is a skeleton of the project. So here we have SRC file where we have the main logic defined. Then we have test file where we'll be defining the mock test, unit test, or any fuzzing files. And this is script. Script is used to deploy this contract on the chain. So this is the skeleton of the project. Now we'll move to this logic where the code is defined. We'll first be building this. So the command was forge build. So I already built it, but let's make a change. So okay, if you see, we have compiled these contracts, but with some warnings, so it's fine. We can ignore it for now, right? So we have our project built. Now we'll run Solidity metrics to get an overview of the contracts that we have here. So we ran this matrix. Now we'll scroll down and we see these are, when we see that there are multiple contracts that all are present in this protocol listed here. And if you see here, these are the columns that this uh, extension gives us, the lines, number of lines, number source of lines, the complexity. So we can pick these contracts based on the number of lines or the complexity scores. But for my methodology, I pick the lesser number of lines of code so that I get a sense of completeness once I audit a contract. So if you see this is 20, this is the main logic of Oracle upgradable. This is 23. So I'll start with this, right? So this is how we should start. Now we're going to see what is the coverage through test. So forge coverage. So forge is the Foundry command and coverage is the command used to see how much percentage of tests are covered in the test cases. So if all test cases pass, this will give us some percentage. See, test cases passed. These were the test cases written in our test files. And these are the files that we have in our protocol. And if you see, these are the functions. This is the function defined in the project, in the contracts, and these are the coverage. So the first one is a script file. We don't need test case for script file, but we should only focus on, we can actually focus on this, but depends on the scope, whatever is the scope, but mostly the scope is the logic of the contract, which is in inside source. So if we see asset token root sol 77 screen, it's not very good, but yeah, it's manageable. But if you see this yellow one, so there could be some scope of finding a bug. So you can manually audit it and we can find the bugs in this protocol. It is not a hard code rule. Okay, if it is green, if the test case coverage is good, you won't find any. You will find all the it's the code written by human, so human can find bugs in human written code. Even if the AI has written it, human can find it. Right. So this is how the process works. Now we have the coverage. Now we have the solidity metrics. Now it's time to run some automated tools. We will be using Slither. So I have Slither installed already for you. Slither. Yeah. So if you see, these are all greens. These are information findings. So this code, the Slither couldn't find any medium or high or critical bug. So these are all green findings. So this is how we should proceed, right? This is automated part. Now we can move to manual auditing. So if you see here, we also used one extension called inline bookmarks. So let me give you an insight of that extension too. So I have, if you see this bottom of this VS Code, there is inline bookmark. But if you cannot see, I can show you now. So let's say this is safe ERC, right? So we need to give this bookmark this. So we'll go like audit info safe. Say okay. So we have bookmarked this. If you see this is blue. So once we click this, it's in file asset token. You see that we have bookmarked with safe. So once we come for a second pass, we can uh, skip this because it's safe, right? But let's say if it wasn't, so we can issue. So if you see the color changed, or like if you say, okay, this is issue for short, you can mark as audit issue, but you're not sure, you will come back in the second pass, you can just use audit, it will be red, right? So in next pass, you can come and give more insight to this function or this line, and you can come back and see what the real issue is. But for this webinar, I'll be picking up a relatively easier code for a manual demonstration. Let's share the screen again. I hope my token.sol is visible,
Yeah, it's visible.
right? Right, great. Great. So we have another contract. It's relatively easier than that protocol. It's very simple project that I've written for you. We'll be following the same process. We'll first build this. I've already compiled it, so if you can see there is no errors, it's fine, right? Now we'll see the coverage. There are no tests that I wrote, so there will be zero. Show, show zero. Yep, see, I haven't written any test cases for functions in this file, so this is zero. So there is a lot of scope to find bugs in this, right? And I'll first walk you through this code. We'll do some put some bookmarks for our pass. When we come back, we'll write a test case in Foundry, and it is a high issue that is hidden in this contract. We'll try to see if we can find it after we get an understanding of this contract. Okay, but let me walk you through it first. So this file has three contracts. One is ownership, one is possible, and one is token. So a file can contain multiple contracts. It depends on the developer how cleanly he wants to write. But okay, this is how it is. Let me walk you through it. So this contract ownership, this is an ownership contract. So it has an owner variable of type address, public variable, and it is assigning this caller of the transaction. Basically, whoever calls the transaction is assigned to this owner, and it has a function owner. So this function, whenever function is called, whoever calls it is assigned as message or sender. So if I call it, I'll be the owner of this function. This contract has a modifier, and this modifier basically checks the ownership. So if I call a function and with this modifier, so it can only be this function, that function can only be called by the owner. This is the ownership contract. We have another contract with possible. Possible is inheriting this ownership contract. So whatever we defined in this contract ownership, it will be inherited by this possible contract. So this contract has a variable called is paused. It's a Boolean type variable, public variable. This contract has a modifier. If not paused, it basically checks if the contract is paused or if not, right? So if we are using this modifier, then the contract won't be paused. And if it is paused, then it will give us error. Now we have a function called paused, can only be called by owner. So we have this defined in our ownership contract, right? So this what this function does is it basically when it is called, it pauses the contract. And same, it's a similar resume is a similar function, can only be called by the owner. And whenever called, this contract resumes from the pause state. This was the possible contract. Now the main contract is the token contract, and it inherits the possible contract. What it does is there's a mapping from address to balance. So whenever we give an address, it gives us the balance. It maps to the balance of the receiver or sender. It has it has a transfer function. Basically, it takes it has a transfer function. It takes two values. So let's say two is the sender's address or receiver's address, just for the or we can use inline bookmarks, or we can just use comments, whatever you choose, it's up to you. Audit info, right? So it will be like two is receiver, right? So let's say 0x1, and how many tokens or whatever value we're transferring, let's say 118, 118 is one ether. So this is what this does. And this is balance. It is same as this is Solidity, but it is same as in any other language like Java or Python. So it will be like balance of the sender, balance sender minus the value, right? This is how balance of sender caller is calculated. Sorry, value, and here we are calculating the balance of the receiver. The same. This is how it is calculated. So this is the token contract. I hope you all understood what this contract, these all three contract does. Now we will write a test case. So I have this is a skeleton of the test file. Let me walk you through, and then we'll write a test case to check the functionality. So I have imported Solidity, this version. So this is the same version that we're using in this file, 0.7.0. So as we are dealing with ABI, so we'll be importing this ABI coder version 2. And this import test and console are basically the libraries, the Foundry. So libraries of Foundry that we need to import when we're writing a test case. And this is the file that we are going to test, right? So now we are, this could be, this is the name of this contract, test contract. So it could be any token or talk test. And we are importing this, inheriting this test contract, which is written in this library, and we imported this now, right? Now we'll write a test case. We'll first declare a function, set a function. It might be overwhelming for you, but be with me. It will be all worth it by the end. Public function. Now we're going to import a token. This token is from the same file that we're going to test. So if you see this, this was here, token, right? That's what we are doing, token. New of type token. No input for there, right? We'll also import ownership, contract. We declare it locally. So whenever we run any test, this setup function will be run. So let's say there are 3 tests in these files. So this setup function will be run 3 times. So every time we run a test, the setup will run. So that is why now we are going to declare this globally. Token of type token, and ownership. Ownership. Now we're going to declare the addresses. Let's say owner, and it is message of sender. I will this address, and we'll be using other address that will be attacker. We could use any address. We're using X1. Now let's declare it in the global address owner. Right. Yep. So let's see if we have written it correctly. Let's run this. This is how we'll run forge test. We haven't declared any test. Let's write a test. Okay. Function. Then let's say we're going to test this function, this transfer, or using test function, test transfer. Right, it will be public function. Let it be empty and let's see if we have written our setup function correctly. Let's run it. Was test. This is how we run the test. Now empty is match test, and we'll write the test name. So it is test transfer. So we can use test transfer. See, it passed. So we haven't written anything. So our setup is successful. So we can write the logic inside this test now. We are going to just test if this transfer works properly. Okay. Now let's say I'm going to use VM prank. VM prank is a cheat code of Foundry where we can prank this contract to be any user. So we'll be let's say attacker. We are attacker, right? We're going to transfer some tokens. Token dot transfer attacker value, let's say 118, and this should pass. We can check it. Assert. Assert is basically we're checking if whatever the condition we're defining inside should be equal. So token dot balances of the attacker. Okay, so we don't know the balance. So let's give some balance to both attacker and owner. How we are going to give it? I'm going to start prank. So the difference between start prank and prank is whenever we call this VM prank, only the next statement will be called with this address of attacker. But if we start prank with owner, what happens is tell you a bit. This statement will be called with owner address. This statement will be also called with owner's address. And all the following statement will be called with owner address until we stop this prank. So let's say we give 10 ethers to this attacker and we give 100 to this. So this will be starting balance. So 100 Ethereums to owner and 10 Ethereums to attacker. This is the balance, initial balance, right? Now we stop the prank. Now if we see, we have to give some balance here to match to assert this condition. So we don't know. I'm not good at math, so I don't know how much we could attack balance of the attacker. So let's say 10 or say 20, 80. We'll check it through Foundry if whatever we have written here is okay or not. We'll run this test again. Okay, wait. So this test failed, but we don't know what exactly failed. So we'll increase the verbosity. This is -v. So 4 V's are the maximum verbosity. 1, 2, 3, you can use any, but we'll use maximum verbosity. Yep. So if you see, we'll we ran the setup function and it is shown in this test. This setup function, right? So we started a prank as the owner. This is the address of the owner. We transfer some balance to this owner address and the attacker's address. Attacker's address is 0x1, which we declared, right? 0x1 is the attacker's address. This is how we declare some tokens to this address. Then we transfer some tokens to owner itself. This is the address of the owner. This is the 1018. This is 118. Then we stop the prank. Then we started our function test transfer, and we pranked as attacker. If you see, this is attacker's address, right? And we transferred some balance to his own address. This is the process. This is what where it does. Now it checks if the balance before transfer and after transfer is equal. If you see, 1018 is not equal to 2018, right? So it should be 1018 now. So if we change this to 1018, bill balance is not 1018. Should pass now. Great, great. So now, if we see this test passes, this is how we run the first test in Foundry. So it's a unit fuzz. We only tested one function with one, with one fuzz. So it's unit test. Now we'll try to find a bug. If you see here, there is a high severity bug here. So this transfer can only be this only can work when the contract is not paused. But what if it is paused? Can an attacker resume this from the pause state and run this transfer himself? So if you see this, this is how an attacker can become an owner. And if you see this, when attacker is an owner, he can resume it. So this is the logical issue in this contract. We'll try to test it with writing a POC. So we'll test bug. It's public function. Rank the owner. Rank as an owner. Rank as an owner. And we'll pause the contract. Right. Now we transfer the same. We'll do the transfer. So according to the logic of the contract, if the contract is paused, we cannot transfer the tokens to anyone. So we'll see if this test passes. Sorry, we need to give in. So this is how Foundry treats a function, a test function, when you write, when you append test to it. Save it. Test bug. Okay. Okay. So it failed because the contract was paused. Now let's become. We know that contract is paused here. Contract is paused. Now we'll become the attacker. We'll prank, become an attacker, right? But the attacker. Now what we'll do is we'll call this function owner. So ownership, ownership, but owner. Now we call that function. Now we'll see We can resume and we'll perform the same. This paused the contract. We became the attacker. We called the owner function. We resumed it and we transfer the function. So if this test passes, it is visible that we became the attacker and we change the state of the contract. Now let's run this. Okay. Great, great. See, we just found a high or critical bug. Depends on how you show it to the protocol. So it is at least a high severity bug. So you change to attacker, you became an attacker, you resume the state of the protocol to resume from paused, and you transfer the token to yourself or be it anyone, and you block the logic of the contract. So this is how we test right POC in Foundry. Now we'll try to do the same through Echidna. Echidna is again fuzzing tool, but we can maximize our fuzzing through Echidna. So we'll put our Echidna here in a same SRC folder, right? And these test files are kept in test folder with token.t.sol. T is represents the test file. And for Echidna, we'll be using this simple Solidity file. This sol is Solidity. So we'll import whatever file we are going to test. And this is skeleton of the Echidna file. This is same as what we did in here in Foundry. We imported test file. We imported token here because we don't this Echidna is not related to Foundry, so it's an altogether different tool. So we don't need those imports which we did here, test and console, right? This is all we need for a skeleton. Now we write our we did setup function and we wrote setup function in Foundry. Now we'll write a constructor. We do not need a setup. Our constructor which will be public. Balances. So we'll test a functionality. Let's say if we are transferring balance to someone, let's say a user has a balance of 10,000, and if you're transferring to someone, so the balance will be lesser than 10,000. So that's a invariant type of thing. We'll test it through Echidna. Let's say we'll declare an array. So Echidna is the address. We'll declare it in a moment. We're giving the balance of 10,000. It gave an error. We have not defined it. We'll define it now. It's an address. And it's Echidna variable. And it is the caller of this. We'll write a function. Function Echidna. So you have to write this Echidna to Echidna. No, okay, there is a Echidna testing function. We have to use it same way. Test balance public returns a pool and we're not changing any state, so it will be a view state. Returning balance Echidna should be less than or equals to 10,000. Cool. So what we are doing here is, so we are giving some balance to Echidna. Echidna is our address, or you can use any variable. I just used it. You can use any. So Echidna is the caller of this contract, and Echidna has some balance of 10,000. So this, what it does is it tests if this contract token would solve. If, is there is a chance that I can get this balance of the Echidna lesser than or equals to 10,000? We'll save it. So to run Echidna, we need to get in that folder where we have our file. So if you see that was file call solution.sol, we're in that folder. Is Echidna. So we run it. Great. Yep. So if you see this test failed, this was a test. If can it there be a chance that balance of the Echidna can lesser be 10,000? So it found a way that if we transfer this token, this is the this 0xFFF is the address of the Echidna, and this is the value that it transferred. So if you transfer some value to this address, so that balance of Echidna will be lesser than 10,000. Will be greater than 10,000. Sorry. So this was a test, and it broke. So if we run it again. Yep. So if you see we ran the Echidna, it failed. Our test case failed, and this is the call sequence it called. We transferred this amount to this address, and this is how Echidna was able to fuzz that condition, and it came to be false. False. So this is how we audit the code. Now there is an homework assignment for you all. So the same way we did with Foundry, we found this bug in this token.sol. We are going to you're going to test it with Echidna and write a file, and then do the same with Echidna. And for any solutions or any hints, you can just ping me on my socials, and there they are. You can take a picture of my socials for any solutions or hints, and you can come back to me with with it Echidna file. I'll let you know if you are correct with that or not. And with that, I complete my presentation and the webinar. And now I'm up for any doubts or questions or any suggestions.
Everyone, the session is open for Q&A. So drop your questions. Arjun, there are a few questions already in the chat box. If you can take them up first.
Sure. So some people have already found the bugs. That's great. That's great to know. So yeah, I guess if possible, I'll share it on my socials. I have just shared my QR code to how to get started in Web3 blockchain. You can ping me on my social. I'll let you know. Yeah. So Chetan, the bug fix would be here is so only owner can change the owner. If you see, there was a ownership function that can be called by anyone, right? So it can be called by only owners. So only owners can transfer the ownership. Uh, People can usual general people cannot, or any tagger cannot call that function owner and take the ownership. So that is how you will fix it.
Yeah, hi Arjun. Good evening.
Hi,
Thank you for the lovely workshop we had. And
thank you.
what my question is that I also do audits on code for Arena and all other things that you just mentioned.
Hmm.
But whenever I go on a code base, I get so overwhelmed by the code, I'm unable to make any sense of it. Right? I know the vulnerabilities that some smart contracts have, like reentrances issues and such. But the code, when I look at the code, I'm unable to make a generalized sense of it.
Hmm.
So how can I get better at that and make a sense of the code? Thank you.
Great, great. That's a great question. So I felt the same when I started my journey in Web3. So, but if you're aware of learning platform called Cyfrin Draft, that is a Patrick Collins channel. Basically, what he does is, so he creates some contracts like first flights. First flights are practice contracts. There you can practice these contracts. So the logic is not very complex. You can go to Cyfrin Updraft. So I'll drop a link. You can ping me on the social. I'll drop a link to you, so you can start auditing those protocols. There he teaches you actually what exactly their practicality is required. So let's say you have an audit on be it any platform, Code Arena or Sherlock, right? So what he does is he creates a code with same way vulnerabilities that those code had in previous time, right? But in a easier way. So that you auditors like you and me who are very early in this stage can find those bugs. So it's a very good start to go. You can use Cyfrin Updraft even to learn and start your auditing journey. I hope I answered your question. Great, Shashank. And any other doubts or questions you guys have?
Chetan has a follow-up question for you, Arjun.
Yeah. So in Web3, it is all very visible. So once a code is on chain, you can view it on. You can view all the codes. Uh, if you have a contract that's deployed on chain, so you can view anyone can view a code. So yeah, it's a little different in Web3. Why is there only specific amount in it? No. So what it does is Echidna creates a sequence. So let's say you ran Echidna one time. It will it will learn the sequence. So let's say you ran Echidna with one Echidna found a bug with one input. Let's say $1,000. We had some huge amount of ETS transfer, right? So if you run it next time, it will have another amount. So Echidna learns it from previous runs. So let's say if with one run it gave you a sequence with value 1, then in second it will give another value. So that's how Echidna does. I hope I answered it. Yeah, I think I answered it, but yeah. So Shashank, yeah, it is Web3 is always booming, so you cannot think if you're saying if you're asking if it's a long term good option for a long future. Ask yourself a question: is Bitcoin token as a token, where is it going? If it is stopping, then the smart contract security is going to stop. I think it will answer your question. Are there any industry recognized certification courses? No, Vinod. There are no certifications in Web3, but you get what is required to get in Web3 is just the knowledge, and uh, hopefully, and I guess currently everything is free, everything is open source, and this is a very good thing about Web3 security. Everyone has open source thing. As Cyfrin Updraft is everything you need. You can learn through Cyfrin Updraft. You can do practice at Cyfrin Updraft. You can actually do auditing at Cyfrin Updraft. So Cyfrin Updraft is one platform for all. Yeah, so Janta Web, as Chetan answered, Cyfrin Updraft is a uh, portal where you can learn everything for free. Sure. Let me share it just now. I've shared the link to Cyfrin Updraft. You all can just have a look. Yeah, because Johnny Time's course was actually a very like he got the initial mover advantage. So there were not many courses at that time, but at that time too, Patrick Collins were doing his videos on YouTube. But now he has his own portal, this Cyfrin Updraft. So you can either view it on YouTube or either go on Cyfrin Updraft. Yeah, Rajesh, Cyfrin Updraft is go-to platform. Yeah, Chetan, uh, if you are learning through Cyfrin Updraft, you will get knowledge of all the language. Currently, it has Solidity and Foundry, but yeah, I think they will move to other languages like Rust, Go, Viper. No, Asik, we don't have a Web3 opening right now. We are full-fledged. You will get on socials if we have any opening for Web3. I guess I pasted one link to a direct message. Let me share it to everyone. So this is the link for Cyfrin Updraft. You all can visit this site and start your journey. Or if you are in between, you can enhance your knowledge. Aparna, I think we are good. We are good to close the webinar.
Yeah.
Great.
All right. All right. I think there is one question by Chetan.
Yeah, somehow. Yeah. But it is totally different. You can view the code, you can run the code on chain or off chain. You can it is similar, but it's not very similar to it.
All right. So thank you, Arjun, for a wonderful session. Thank you, everyone, for attending this webinar session by Arjun. So we are putting up a feedback link in the chat box. I would request you all to let us know how you found the webinar. We would love your feedback to make our sessions better and come up with much more interesting webinars in the future ahead. Thank you so much. And everyone have a wonderful session. Have a wonderful weekend. Thank you.
Thank you, everyone.
Thank you, everyone.